Welcome back to the deep dive. We're jumping into section 5 of that ENP study guide material you shared.
That's right.
Today, it's all about something really fundamental to 911, how the system, especially the legacy one, actually stays running, and crucially, how it figures out where you are.
Survivability, reliability, and location. Yeah, absolutely critical stuff.
We want to unpack how it handles calls, finds you, deals with challenges like complex buildings or mobile phones. Basically, cut through the tech talk.
Sounds good. It's a complex system designed to keep working even when things go wrong. And it's had to evolve a lot.
Definitely. So let's start at the beginning, the old landline call. Your sources lay out the basic path. Where is it trying to go first?
Okay, so for a traditional landline, the first stop it's aiming for is the primary E9-1-1 tandem. You can think of it as a selective router.
The main traffic controller, sort of.
Exactly. Takes the phone number, the ANI, automatic number identification, figures out which PSIP covers that address, and sends the call there.
Simple enough when it works, but what if it doesn't? What if that tandem is down or the connection's cut? Legacy systems have backups, right?
Oh, absolutely. They have to. The material, especially that figure 213 you sent, shows this really well. There are built-in fail-safes.
Okay.
So if the call can't reach that primary tandem, maybe a fiber cut, maybe the tandem itself has issues. It doesn't just die. The system automatically looks for another path.
And what are those other paths? Is it just one backup?
No, there are layers. First, it might try a secondary E9-1-1 tandem if one's configured. If that's not an option, or maybe the issue is bigger, it could route the call straight to an alternate PSAP using their regular 7 or 10-digit emergency number. The system knows these numbers.
So it bypasses the tandem system entirely in that case.
It can, yeah. And the source material also mentions if the call first tried using inter-tandem trunks, it might specifically retry that secondary tandem. It's about having pre-planned escape routes.
Got it. Multiple options depending on what failed.
Precisely. And one key concept for making this super reliable, mentioned in the sources, is this quad matrix arrangement.
Quad matrix. Sounds intense.
It kind of is, but it's clever legacy design. The idea is every local phone switch, the end office, has dedicated lines, dedicated trunks, going to both the primary and the secondary E9-1-1 tandems.
Okay.
And then every PSAP is also served by both of those tandems.
Ah, I see. So multiple paths from the source, multiple paths to the destination, all interconnected.
You got it. It drastically cuts down the chance that a single point of failure, like one tandem going offline or one trunk group failing, takes out the connection between a caller and the PSAP.
That level of redundancy, especially in older infrastructure, is actually pretty impressive.
It really is. It was built for reliability.
What about the phone number itself, the ANI? If the system doesn't get my number, how does it know where to send the call? Does it just guess?
Well, not exactly guess, but it has a fallback. The sources explain this default routing. If the ANI doesn't show up or isn't recognized for some reason, the system can route the call based on the NXX code.
The NXX, that's the first 3 digits after the area code, like the old exchange code?
That's the one. Historically, that NXX was tied to a specific geographic area, a rate center, served by a particular phone switch.
Okay.
So the 911 system database knew which PSAP usually handled calls from that NXX's rate center. It uses that as a backup to get the call to the most probable PSAP.
So even without the full number, it's got a decent geographic clue. But hang on, doesn't number portability mess that up? You know, when you keep your number but move?
Good point. Yes, it absolutely complicates things. The sources mentioned this NXX default routing worked well until geographic number portability, GNP, became common.
Right.
Because now your number's NXX might have zero connection to where you physically are or which switch serves you. So post-GNP, that default might have to rely on something less precise, maybe just the trunk group the call came in on from the switch. Still gives a location hint, but fuzzier.
Shows how tech changes ripple through, doesn't it?
It really does. And what's fascinating is how much resilience was engineered into that old network. But, like you hinted, getting the call to the PSAP is only half the battle. They need to know where you are.
Yeah, and that's where things got really complicated fast, especially when we moved away from simple landlines.
Exactly. Because a single landline usually means a single fixed address. Easy. But then came MLTS multi-line telephone systems.
What we used to call PBX systems, like in offices, hotels.
Yep, exactly. Businesses, campuses, hotels, hospitals. Your sources rightly highlight the huge location problem these created for 911.
What was the core issue there?
Well, you've got potentially hundreds of thousands of phones inside a large building, or maybe spread across multiple buildings, maybe even different sites,
Mm-hmm.
all running off one central phone system. But when
Mm-hmm.
someone dialed out, especially for 911, that system often just sent the main billing number or the main listed number for the entire organization.
So if I called 911 from my desk on the, say, 20th floor of an office tower,
Yep.
the 911 operator might only see the street address of the building itself, not my specific location in it.
That was exactly the problem.
Mm-hmm.
Knowing the building address is way better than nothing, obviously, but in a large, complex structure. Finding someone on the correct floor, in the correct wing or room, that takes time responders might not have.
And this wasn't just theoretical, right? There were tragic cases.
There were. And the material explicitly brings up Kari Hunt and Kari's life.
Yeah, tell us about that.
It's a heartbreaking but pivotal story. Kari Hunt was attacked in a hotel room. Her daughter, who was just 9, tried repeatedly to call 911 from the room phone.
Oh, no.
But she couldn't get through because the hotel system required dialing 9 first to get an outside line. She didn't know that. Kari tragically died.
That's awful.
It spurred major action. Kari's law, passed in 2017, tackled that head-on. First, it mandated that any MLTS installed or upgraded has to allow direct 911 dialing. No prefix needed.
Just dial 911 straight through. Makes sense.
A critical safety fix. But Kerr's law had a second, equally important part. It required that these MLTS provide a dispatchable location with the 911 call.
Dispatchable location. And then BAUM'S Act came along and defined that term more clearly.
Exactly. Building on Curry's law, BAUM'S Act in 2018 put teeth into that phrase. The source is, quote, the definition. It's the street address plus. Additional information such as room number, floor number, or similar information necessary to adequately identify the location of the calling party.
So no more just 123 Main Street. Now it needs to be 123 Main Street, 415, Suite 1502, or something like that.
That's the goal. Giving responders the specific within the building information they need to find you quickly. It's huge.
And there were deadlines for this.
Yep. Phase rollout. Your sources mentioned the effective dates January 2021 for fixed-wired MLTS devices, January 2022 for non-fixed wireless MLTS devices connected to the system.
Okay.
And while the material shows some older ways MLTS tried to provide some location data, like private switch ALI, PSALI, shown in those figures.
There's 214, 215, 216, yeah.
It really emphasizes how Curry's law and BAUM'S Act mandated a much more specific and reliable level of detail. It forced the industry to solve that internal location problem.
So if you work in a big company or stay in a hotel now, dialing 911 from their phone system is designed to pinpoint your location much better. That's a direct safety improvement for everyone.
It absolutely is. Which naturally leads us to the other big location disruptor, wireless calls, cell phones.
Right, because that changed everything. How did wireless 911 start out? Pretty basic, I imagine.
Extremely basic. The sources call it basic 911 or sometimes phase 0. Back then, a 911 call from a cell phone was often just treated like dialing a regular 7-digit administrative number for the police or fire department.
So it might not even use the specialized 911 network.
Often, no. And critically, it usually provided zero location information, maybe not even your callback number. Basically, the PSAP knew someone with a cell phone called, probably somewhere near a particular cell tower, but that was about it.
Not very helpful if you're lost or injured somewhere unfamiliar.
Not at all. So the FCC had to step in and mandate improvements. That led to enhanced 911 or E9-1-1 for wireless.
And that came in phases. Phase I first.
Right. Wireless phase I was the first big mandated step starting in the late 90s. The requirement was for wireless carriers to deliver 2 key pieces of information: the caller's callback number and the location of the cell site and specific sector handling the call.
Okay, so at least they knew which tower you were near and roughly which direction from it.
Exactly. A big improvement. And the sources mentioned the tech involved things like pseudo ANI, ANI, and ESRK or ESRD for routing.
Can you walk us through that phase I flow, maybe a bit simpler than figure 217?
Sure. Basically, you make the call. Your phone hits the nearest cell tower sector. The wireless network knows which tower sector that is. It bundles that cell sector info with your callback number and a temporary ID number for the call to pANI or pseudo ANI. This packet of info is sent ahead of your voice call to a control point in the network. That control point uses the cell sector info to figure out which PSAP should get the call. It tells the 911 tandem where to send the voice call, and it sends that pANI along.
Got it.
The PSAP gets the voice call. Their equipment then uses the pANI it received to do a quick database lookup, querying the ALI database. For Phase 1, the ALI database just contained the address of the cell tower associated with that pANI or sector ID.
So Phase I delivers the callback number and the tower's address. Not your specific location, but the tower's. Still, way better than nothing.
Absolutely. Provided some geographic context. The sources do note that Canada had similar requirements but used different technical methods, not the NCAS signaling mentioned for the U.S.
And obviously just knowing the tower location wasn't enough, so that led to Phase 2.
Exactly. The push was for much better accuracy. Wireless Phase 2 aimed to provide the caller's actual estimated location, usually as latitude and longitude coordinates.
Okay, actual coordinates, how do they get that into the system? Your sources mention wireline compatibility mode, WCM.
All right, WCM was one key approach. The idea was to make the wireless location data fit into the existing ALI database structure used by landlines as much as possible.
How did the call flow change for Phase 2 based on Figure 218?
Okay, so the beginning is similar call hits the tower, goes into the wireless network. But now, the network doesn't just rely on cell sector. It activates its dedicated location determining systems.
Like the MPC or GMLC mentioned.
Precisely. The Mobile Positioning Center or Gateway Mobile Location Center. These systems use various technologies, which we can get into, to calculate the phone's actual geographic coordinates.
Okay, so they figure out the lot line, then what?
Once they have the coordinates, the MPC GMLC generates the pANI for the call and associates those coordinates with it. It sends this info back to the part of the network handling the call routing.
Right.
The voice call goes to the 911 tandem. pANI gets passed along. When the PSAP receives the call and their system queries the ALI database with that pANI. The ALI database, which has been upgraded for Phase 2, now returns those latitude and longitude coordinates that the wireless network calculated and provided. So connecting this to the bigger picture, Phase 2 was a really significant technical lift. It wasn't just about finding the phone, it was about calculating its coordinates and then feeding that dynamic data into a system mostly built for static addresses. Moving from identifying infrastructure of the tower to trying to pinpoint the device itself.
Which naturally raises the question, how do they actually calculate those coordinates? What's the tech behind it?
Right, and your sources break down the location determination technologies into a few main types.
Handset-based, network-based, and hybrid.
Exactly. It depends on whether the phone itself is doing the calculation, the network is doing it, or it's some combination.
And GPS is a big one, obviously. Handset-based.
Yep, global positioning system. Your phone listens for signals from satellites orbiting Earth. Needs a clear view of the sky. Generally works great outdoors. But as we all know...
Well, indoors or in cities, not so much.
Right. Obstructions are a problem. The sources mentioned is DoD origin, too.
They also list DGPS and AGPS. Differences.
EGPS, differential GPS, uses ground-based reference stations to broadcast corrections to standard GPS signals, making it more accurate. AGPS is assisted GPS. Still handset-based, the phone calculates the location.
Okay.
But it gets help from the cellular network. The network can provide data like which satellites are likely overhead, helping the phone lock on faster and sometimes improving performance indoors or...
Needs a specific chip in the phone, though.
Makes sense. What about the network doing the work? UTDOA is mentioned.
UTDOA stands for Uplink Time Difference of Arrival. This is purely network-based.
How's that work?
The network uses multiple cell towers to listen for the signal from your phone, by precisely measuring the difference in time it takes for your phone's signal to arrive at each of those towers.
Ah, triangulation based on time. Pretty much, yeah. The network calculates your position based on those time differences. Big advantage. It doesn't need a special GPS chip in your phone, and because it relies on terrestrial cell signals, it can often work better indoors where satellite signals might be weak or blocked.
Interesting. So different methods with different strengths and weaknesses.
Definitely. And the sources make a really crucial point here. The difference between the location you get on your mapping app versus what's needed for 911.
Yeah, that seems important.
It is.
Yeah.
Commercial apps, like your map, might use GPS, Wi-Fi positioning, cell tower IDs, maybe even Bluetooth beacons, a whole mix. And if it's off by 50 or 100 feet, usually no big deal.
Right.
But for 911, the standards are way higher. They need reliable accuracy, high confidence in the result, and it needs to be delivered consistently and quickly with the call. It's a much more demanding requirement.
Puts it in perspective. Getting location that precise under pressure for emergencies, it's complex.
It really is.
And even with Phase 2 coordinates, there was still that massive gap. Knowing location inside buildings, right?
Exactly. That remained the huge challenge. Phase 2 gave you the dot on the map, the horizontal X and Y coordinates. But was the person on the first floor or the 40th? In a sprawling mall, big store. That vertical location, the z-axis, was missing.
And your sources say the FCC really started pushing hard on this indoor problem more recently, around 2014.
Yes, a major focus shift. Recognizing that a huge percentage of wireless calls come from indoors, they started developing rules specifically for indoor accuracy, focusing on that z-axis, the vertical component.
What kind of accuracy are they mandating?
The target set by the FCC, as detailed in the material, is pretty ambitious, achieving vertical location accuracy within 3 meters, so roughly floor-level accuracy for 80% of indoor wireless 911 calls.
3 meters. That's tight. And they put deadlines on the carriers to make this happen.
They did. Phased deadlines requiring carriers to deploy technology capable of providing the z-axis or vertical location information.
The sources mention specific dates, like early 2022 and 2023 milestones for deployment in certain areas or percentages of buildings, leading up to a final nationwide deadline around April 2025.
Those are the types of timelines outlined, yes.
Yeah.
Clear regulatory pressure to develop and deploy solutions. The material also touches on technologies envisioned to help, like using the barometric pressure sensors that are now common in smartphones.
Right, because air pressure changes with altitude.
Exactly. Those sensors could potentially provide a good estimate of floor level within a building. What's really striking here is how regulation is directly driving innovation in such a tough area. Pinpointing location vertically inside diverse buildings, old, new, concrete, steel, it's incredibly challenging technically. These mandates show a clear push.
But it also raises that question, how do you make sure it works everywhere, in every type of building? That seems like a massive hurdle still.
It's the key challenge. Universal deployment and consistent performance across hugely varied indoor environments. That's the ongoing work.
Definitely. Now, before we wrap this section, the sources give a brief mention to FirstNet. What's that about?
Yeah, FirstNet is important context, though a bit separate from the legacy 911 call routing itself. It's the nationwide broadband network built specifically for first responders.
Police, fire, EMS.
Exactly. Think of it as a dedicated, high-priority cellular network just for them.
And the point is reliability during emergencies.
Precisely. When a major incident happens, commercial cell networks can get totally jammed with calls and data from the public. FirstNet gives responders their own dedicated lane, ensuring their critical communications, voice, data, location sharing, video feeds get through reliably, even when commercial networks are overloaded. It's about enhancing the whole public safety communication ecosystem.
Got it. Okay, wow. So looking back at this section of the material, we've covered a lot of ground. Started with the surprising resilience of legacy landline 911, those backup routes, the quad matrix.
Then tackled the MLTS problem, how hotels and offices hid location, and how Kari's Law and BAUM'S Act demanded that crucial dispatchable location getting help inside the building.
Jumped into wireless, the evolution from basic 911 to phase I finding the tower, then phase 2 aiming for actual coordinates using GPS, AGPS, UTDOA.
And the complexities of getting that wireless data into the ALI system.
Finally landing on the current big challenge. Indoor location and the regulatory push for Z-axis, floor-level accuracy, using new tech, and facing those deployment deadlines.
It's quite the journey.
All these intricate details, all this evolution, it's what underpins the system trying to reliably find you when you call 911.
And yet, despite the incredible progress, from just hoping the call got through to pinpointing a floor in some cases, reliably locating everyone everywhere, especially deep indoors in complex buildings, that remains the ongoing challenge. The puzzle isn't completely solved.
That leaves us with a final thought, doesn't it? What other breakthroughs or maybe different approaches might finally crack that universal indoor location problem, conquer those last few meters for every single call? Something to definitely keep an eye on.
Absolutely. It's vital work.
Thanks for walking us through this deep dive into the material.
My pleasure.